Let's get some functions rolling.
Yeah, so when a problem says write y as a function of x, it wants you to write a formula
Why?
that, like, y and x are things. Like, it could be something else.
Why?
No, stop.
Oh.
Okay? The point is, if it says write something as a function of something else, it wants you to write a formula that's solved for the first thing.
Right.
And only has
the other
thing on the right side.
Right.
So on example 2, we're going to work with the area of a circle.
Yeah, let's do.
Which is
pi r squared. A equals pi r squared. That's the area of a circle right there.
And we're writing it. We're writing area as a function of its radius,
which is a as a function of r.
As a function of r, which we actually have.
Right.
Because pi is a number.
Right.
Not
pi is
a
number.
variable.
That is correct. And you'll forget that later this year, and I don't know why you'll forget that, but you will.
But just remember, pi is a number.
Yeah.
So it's okay. Now, if we want to write the area of a circle as a function of its diameter.
Oh boy.
Now let's think about the connection that we have here. Can't we equate something with the radius and the diameter?
Yes, we can.
How many radiuses?
There are 2 radiuses for every 1 diameter.
Okay. But in our formula here, we've got r. And so we want to plug in r. So we need to solve this.
So look at that, half a d.
R equals half a d. So we're going to take what the formula normally is, but instead of
squared. Oh, I know. You're going to put 1/2 d, close parentheses, and square that puppy.
Yes.
Now we could be, okay, you could be really uber nerdy.
Or awesome.
Or awesome.
Because I think that's...
Yeah, some of us know where we belong.
Yeah.
This would be 4 on the denominator.
Right.
Okay, so to
1/2 squared would be 1/4.
1/4. So you could do this. You could do pi over pi d over 4. How about that? D squared, of course.
Oh, yeah. What the whole point of that is the squared goes to both of these.
Right.
So a half squared is a 4th.
Right.
D squared is D squared. Pi's still in front, and it still equals a.
Right. Or if you wanted to, you could simply have
you could write
a variety
of 1/4 pi
d squared.
Honestly, I think that probably looks the neatest personally.
Cramming it all together though. Come on.
Yeah, well.
All right.
Now this one's tricky.
The circumference
C.
That looks tough.
So we're trying to, let me switch colors. Yeah. We're trying to write a equals pi r squared, but we don't want r, we want c for circumference. Okay. What is the formula for circumference?
2 pi r.
So that means we want to be able to put c in here.
Yep, so we're going to have to solve that puppy for r.
Tricky.
It's tricksy.
So r equals c over 2 pi. We're going to put that right where that r is.
So it's going to be, can you see that?
I can see that.
Okay. The students may not. That's a little better. I like that color.
Equals pi, and in parentheses,
c over 2 pi squared. Now, I love how this one looks when it's, well, the pi's canceled out, sort of.
But see, everything in parentheses has to get squared, right?
So pi actually gets a square on it. So c squared over 4 pi squared. And
so a pi cancels out.
Right.
But we're still left with a pi.
Still left with a pi. So you got c squared over 4 pi's. I love pies.
Are you talking about
chocolate pies, cherry pies, pumpkin pies, apple pies?
The whole point, though, is that
eating some pie.
We wrote area as a function of the circumference. So a was on the left, c was on the right.
Right.
No other variables were involved.
Correct.
Or harmed in the making.
That is correct. This was variable safe production.
Yes.
Yes.